презентацию нового оборудования компании Guralp. Мы пригласили двух представителей посетить ваш замечательный институт и рассказать про новинки, которые они сделали за последний год. Сейчас я не буду подробно на этом останавливаться. Вы будете смотреть презентацию, они будут про это рассказывать. Презентация будет на английском. Если у вас будут по ходу презентации какие-то вопросы, что-то непонятно, вы можете останавливать презентацию, задавать вопросы, я, соответственно, переведу и переведу обратный ответ. Вот. Прошу, представляю, точнее, Вилаис и Ханна Питерс. Все. Можете, you can start.
Okay, thank you very much for letting us come to do a presentation today. As Sergey said, my name is Will Rice. I graduated from University of Cambridge last year. I studied geology and geophysics, and I had a bachelor's and a master's in both those subjects. So today we're going to talk a little bit about our new equipment and our new software and answer any questions that you might have. If you need me to slow down, then please tell me. And if you have any questions during the presentation, then stop me and Sergey will translate. So to start with, who are we? Guralp, we have been making lots of different types of seismometers, accelerometers and ocean bottom systems for around about 30 years now. So we specialize in very high sensitivity and low self-noise instruments. Instead of using MEMS technology, we use force feedback technology. This helps us achieve very, very high sensitivity and enables us to pick up a very wide range of frequencies. Instead of just providing single instruments, we can also provide complete solutions. So we can help provide a solution for a whole dam, for instance, or a whole array. We have experience ourselves of monitoring, using an array ourselves and maintaining that array as well. So we know about all the difficulties of installation, we know about all the difficulties of keeping that array working. So it's not just producing and selling the instruments, we know how to maintain them as well. As I said, we have a very wide range of applications for our instruments, so I'll go from left to right. Using our instruments on volcanoes, so we can use our very rugged, our very hard-wearing instruments to go on volcanoes and very harsh environments such as the Arctic or the Antarctic, and we can make sure that our instruments are able to work in a variety of different environmental conditions such as extreme cold or extreme heat or very corrosive environments like you might find on a volcano. And then moving on into earthquake early warning, I will speak about this a little bit later on, but using our new technology and our new digitizer systems, we are able to provide very, very fast warnings of earthquakes happening nearby or very, very far away. And this is using a combination of very, very fast processing and very, very up-to-date new software and protocols. Moving over to here, we have a lot of new instruments. We've brought over today the Fortis, which is our new accelerometer. This is a very new instrument that is going to replace our 5T series. I know that many of you will be familiar with 5T or 5TD. In a few years' time we will start to phase out this instrument, and this is the new and upgraded version of the 5T, but I will speak about this a bit later on. And then just on the right we have boreholes and OBS, so OBS, ocean bottom systems. These are very complex instruments, but Guralp prides itself on being able to produce and manage these instruments very, very well. So now we move on to talking about our new equipment. So many of you will be familiar with these instruments up here. These are our classic broadband seismometers, perhaps the instruments that Guralp is most famous for. But we have now started to develop new digitizers. So this is the Minimus, which we have here. In the last 1.5 years, 2 years, this has sold around about 600 units around the world, so it's very, very popular. And our new accelerometer series, which is a combination of the Fortis and the Minimus. Over here we have the new borehole which we have developed called the Radian, which is on the desk here. Don't worry, at the end you'll all have a chance to play and interact. And then we have also been developing our software down the bottom as well. So to start with, the new Fortis accelerometer. So this is going to replace the 5T in a few years' time. So in a few years we won't be producing the 5T, and this is the new upgraded version of the 5T. So we looked at the components inside the 5T and we thought, how can we make these better? And we have adapted the mechanics of the 5T components. They're slightly smaller. They are now able to go down to a much lower self-noise, so we can monitor frequencies with a much greater dynamic range. So as you can see, it's over 160 dB now at around about 20 Hertz. And as you can see down here, we have adjustable gain. So on the bottom of this instrument we have a small switch, so it is very easy to switch between the gains that you require. The whole idea of this instrument is that it is very simple to install, very simple to use, and then combined with the software that we have developed, it's also very simple to interact with. So everything should just be very easy to install. There's no need for complicated manuals. We'll give you a very simple manual and everything is very simple to set up. As you can see, it's also quite a lot smaller, so we can go into very remote locations. You don't have to carry it on your back with a huge rucksack. You can get multiple units inside a small bag, and you can take students with you who can take all the heavy loads for you. Moving on to the Minimus and the Minimus Plus. So the Minimus Plus is just a bigger version of the Minimus. So the Minimus has 4 channels for digitizing. So this means we can plug in, say, a Fortis. So that will have 3 seismic channels, and then the 4th auxiliary channel could be, for example, for infrasound or any other station that you would like to digitize. In the same way, we have the Minimus Plus. This has 8 channels. So this could have, for example, 2 triaxial instruments, so a broadband sensor and a strong motion sensor, and then you have 2 extra auxiliary channels as well. In addition to these channels, we can also plug in a digital input as well. So right on the end, the Radian here has a digital output. So coming out of this cable, the signal is already digital. We don't need to digitize it again. So this means if you use the Minimus Plus, we can have a total of 8 analog signals going into it and a digital input, and then we could output all of these signals simultaneously. So you only need one digitizer to do a lot of work for you. Now the main focuses for these instruments are very, very high sampling rates. So we can go up to 5,000 samples per second. Sorry, I'll just move over so I can get to the mic. And very, very low latency protocols. So we have developed a new protocol for streaming data. This allows you to adapt the size of your packets of data that you are transmitting if you have a very limited bandwidth, and it will adapt according to your bandwidth. So this means that you can stream your data very, very quickly, and it means, especially for earthquake early warning systems, this is very, very useful. In addition to this, we have a 64 gigabyte micro SD card as standard, and also inside we have another 64 gigabyte SD card. So you can remove the one from the top and change it and put another one in. If the first one becomes full, then the Minimus will automatically start recording to the other SD card. So you have a dual redundant kind of system. This means that if you are unable to access your station, or if something goes wrong with the first card, then you will not lose any data. It also means that if you lose your network capability, so if you lose your communications link, then we will start recording all the data to the SD card instead of transmitting it all. So regardless of what is happening with your network, you will always get all of the data. There will never be any break. And as I said at the beginning, this is a plug-in and play, as we like to call it. It's very, very simple. It's very, very easy to use, especially with the software that we have provided. So a little bit about how we might set this up in an array. So minimus units can communicate with each other to vote on events. So we would set up a master minimus. So this is a master minimus, and then these are slave minimuses. So the slave minimuses will send their signals, send their events to the master if they've been triggered. I'll talk about triggering a little bit later. And then the master can decide whether the event is real or whether there has been a false positive. This means that we can vote based on quite a large number of instruments, and then we can reduce the number of false positives. This also means if we have one subarray like this, we can make several subarrays join into one server. And then in a similar way, we can make this sort of regional array into a much wider national network, if you like. Now, I've talked about the Fortis and the Minimus. Recently at AGU in December, we launched the Fortimus. So this is a digital accelerometer. Now this combines all the technology in the Fortis and all the technology in the Minimus and puts it all together into one package. This will go from DC to 200 Hertz, so we've expanded the frequency bandwidth. In the same way to the Fortis, it's very easy to install. Now this will have power over Ethernet, so there is no need for lots of complicated cables to take the communications and the power. We can power it just using one cable. And we also have multiple timing options. So if you are not somewhere where you can get a GPS signal, for example if you are in a dam, or if you are under a hill, for example, in a vault, then we can use PTP or NTP timing protocols, where you could have a GPS station somewhere else perhaps, or you could use the timing coming over the Ethernet signal. Also, I haven't mentioned yet this touch screen. So when you're in the field installing, this has a number of different options where you can configure the instrument to set it up exactly how you want it, and then you can walk away knowing that you have set it up correctly without having to bring a laptop. It's just a very, very simple way of installing. Now moving on to our Radian, this is a revolutionary advance in technology for Guralp, and we're planning on using this kind of technology in the future for many of our other instruments. So the Radian is this long cylindrical instrument on the end of the bench. This can be made into a post hole or a borehole version, and as you can see its maximum depth is 2,000 meters. Currently we have these instruments in depths of around about 1,300 meters. Now one of the key aspects of this instrument is that it can function at any angle or any orientation. So it does not need to be vertical. It can function like this, or upside down, and it does this by using two sensors at the very top to understand what orientation it is at. It then combines the normal force feedback sensors to do all of the sensing for you, and it uses these two only to figure out what orientation it is at. So this is especially useful if you are using a very old borehole that has maybe become misaligned, or It's also very good if you're placing it into sediment and the sediment is prone to moving through perhaps a landslide or just due to soft sediment deformation. We have a full specification sheet, a brochure for this instrument where you can look at all the specifications required. Just some simple analysis here. We have a very broad frequency range for this instrument, so 120 seconds to 200 Hertz, and this is because this sensor, the force feedback mechanism, is partly digital, so this has enabled us to achieve this very, very broad frequency range. This sensor is also very, very small, so it can fit inside this cylinder. It's around about 1/8 of the size of the sensor from a 3T, for example. Now, with a lot of instruments, you have to input the poles and zeros, the calibration data, you have to put that in manually. However, the Radian already knows this within itself. So when you plug in the Radian to the Minimus, it will be able to tell the Minimus what calibration data it has. So there is no need to input lots and lots of values manually. So this is why we think it is a smart instrument. And you can also stream all of this metadata. So this is the software that we would use, and we can use any number of these channels. So we can stream the seismic channels, we can stream any of the internal channels, and we can also stream the metadata as well. So you have lots of different options. Another key advantage for the Radian is that you can join them all together. So we can have up to 8 Radians all in one hole, and we can connect these all together. So this may be useful if you're trying to do vertical seismic profiling. For example, this is sometimes used in oil and gas applications, or for example, this diagram on the right, this is some data from Bishkek, and this is monitoring basin amplification. So this borehole goes down into soft sediment. As seismic waves come through the sediment, then they amplify, and we can monitor how they are amplifying throughout the sediment. It's also very good if we are going to install it underwater, for example in a reservoir, and we want to monitor how the sediment is moving through landslides. Now, we've talked a lot about our new instruments. Obviously, we're still making all of our normal instruments, our 6T, our 40T, our 3T, our 3E SBC. All of these instruments are still being made, and we just brought our newest equipment with us. However, the diagram here just demonstrates how we can plug lots of these instruments all into one digitizer. So this will reduce cost, it will reduce installation time, and it will just generally reduce the complexity of any installation. Now we'll move on to the new software. So I will talk about it a little bit now, and then we will bring the software up onto the screen, because then it is much easier to view and see how everything works. So when we thought how to make some new software, we thought it needs to be very simple for the user. It needs to be very easy to use by someone who maybe doesn't have that much technical knowledge. So we made this new software called Discovery. So Discovery works with the Minimus and the Minimus Plus. So we can stream all of the data coming through from any instrument plugged into it. And as I said, that can be multiple different channels. We can also use Discovery to set up triggering and voting. So I talked about voting earlier. We can decide which instruments are reliable, which instruments are in a noisy location. And for example, if we have one station that is near a railway line, and this is a very noisy environment, we can give this a low scoring. If we're near a station, or if we're using a station which is in, for example, bedrock, this is a very quiet station, we can say this is a very reliable station. And when we are setting up our triggering mechanisms, we can say that the one in the quieter place is perhaps more reliable than the other one. So Hannah has the discovery. Oh, that's definitely not. Look. I think it's because we have the. We can bring it up in the session. Should we go back to the slides and then we
sorry, we can carry on.
We can go on the slides and then we can go back to the software. Yeah. Thanks. Okay. Yeah.
So the discovery software, it's only used with the new digital technologies, but these digitizers can be used with our previous software. So Scream is one of the most commonly used. Discovery is completely compatible with these instruments. The Minimus has a Seedlink server inside, so you can stream over Seedlink. It stores all the data to its memory card in Miniseed. With our Discovery software, we stream in data through Seedlink, through Guralp protocols, of which we have 2 protocols. GCF is the most common, but GDI is our new low latency protocol, and I'll plug it in and show you how that streams through really quite quickly. Will's mentioned that the software is it's very user friendly. There's drop-down menus. It also allows you to select many different settings without having to go through a control sort of protocol. One other thing we need to mention is the triggering capabilities. So this little compact digitizer here, it's been designed to be used for earthquake early warning applications. And for that, we've had to develop quite a lot of triggering mechanisms and look into how we can trigger data very quickly. One of those ways is, of course, STA-LTA, which is the well-known way of triggering. We also have parameter calculations inbuilt, so if you want to do local alerts, you can trigger within your local site and it will issue you out alerts giving you PGA, peak ground acceleration, PGV and PGD. We've worked with a protocol called CAP. This is Common Alert Protocol. It was developed by Google, so it's a well-known global protocol. And using this type of protocol, we can actually issue alerts directly from the Minimus digitizer itself in a local site. Now, these alerts are issued in the format of an XML file. XML is very user-friendly, readable text file, and these alerts can be sent to either other CAP receivers, so that could be within your network, sending between Minimuses, or it could be to a phone as an SMS or an email. So this is a way of distributing alerts from sites. Over here on the left you can see there's a map. So this will show you where a trigger has happened. So if you had a network and a trigger was issued, then the map would bring it up, show you exactly where it is. You can then also get all the relevant information directly through a simple CAP message. So the text files on the right are the XML files. We can zoom into these later and I'll show you them. And then the information in the middle, that will give you your STA, LTA information and all of your PGA, PGV, PGD, the different protocols that one really requires when you're looking at alert systems. Now this can be earthquake early warning, but it could also be civil structures, for example pipelines, shutting off gas pipelines if there's a certain event close by. The ability to transfer this information very quickly is a real big key, so low latency. The Discovery software, it works with a cloud registry, so you can register all of your different sites to a cloud. Guralp use an Amazon cloud account. There are many available. Here's a standard image of all of your different sites. It uses a traffic light scheme, so you can clearly identify if there is any errors on your sites. For example, the top one, there's a little red dot over the timing signal, so you've got no GPS lock at that site. All of the text in the middle, this gives you your IP addresses for individual sites, how long it's been running, Latin long. These are all the key information that as a network operator you really need to see visually and very quickly. You can then dive into by selecting individual stations, and you can see the web page for that station, which shows you summaries, allows you to change settings and configurations. The Minimus in addition has Bluetooth capabilities, so you can connect to it with your mobile phone, mobile device, and you can stream the data through your mobile, through your laptop or iPad, and you can also change basic settings through Bluetooth. So this could be sampling rates, for example. It'll allow you to issue reports about your site. So this is sort of a very nice and easy way of looking at the state of health of your site without perhaps digging it out of the ground. We'll spend some time later with these instruments all plugged in, and I'd like to show you the features within the software after this presentation. But the final two slides, we just want to quickly mention ocean bottom seismometers. Guralp's been producing ocean bottom instruments for, since we started, for 25 years now. We've started with building ocean bottom boreholes off the coast of Japan, really quite complex solutions. And now we have a range of different instruments for different types of environments. The technologies that are within our new equipment, so the sensors that are within our Radian instrument, these are now being repackaged into different outer solutions for ocean bottom. So we can provide portable systems or cabled systems. For the portable systems, our ability to have a component that can work at any angle allows you to have a system without a gimbal. Now, a gimbal is one point of failure within OBSs, and we've recognised that with previous designs. But now we have a new system that does not require that. So it's a real revolution for ocean bottom seismic equipment. And in the next year, you'll probably see Guralp is developing and releasing quite a lot of new OBS solutions. It's becoming a very popular demand these days. And we've installed them all around the world in very high quantities. Here's just some examples. We've got a big array in Australia, and they use active seismic sources as well as passive for broadband portable systems. And then here's some that we have in stock on the left at Guralp. So we've got some portable instruments here. And like I say, this is an area where we're really focusing quite a lot of effort in, and using the technologies that we use in surface instruments and the digitizer technologies that we've developed and packaging them into other kind of applications. So this was a very brief overview of what Guralp do, what we produce, some of our newer equipment. Really like to spend some time talking about the software in a minute and showing you some of the software. But if you have any questions about what we've just presented, please do let us know. Thank you.
Спасибо. Thank you for your presentation. And Hannah, now we have a question for you.
Thanks again for the presentation. And first of all, you have completely omitted the GDI. And you have mentioned that you do have the next generation protocol, but in a short overview on your website I've seen it's called open source.
Yes.
But a bit digging, I've reviewed a bit the repository that you have on your site, but there's a client only. There's no server software, open sourced, and the license that says it is not a GPL. How do you manage to push that protocol to systems like Earthworm or so?
Yeah, so we've worked with Earthworm and SysComp, and they've actually allowed us to develop a plugin into their software. So we work with Gemper and ISTI, and they've now allowed us to plug in with the GDI protocol, so it is fully compatible with Earthworm and SysComp because of the plugin. Now if you want more detail about the open source, I'd speak to you away from here and probably put you in touch with our technical support team about that.
That's great. And I have a small another question.
Yeah.
The Minimus
Yes.
and the Fortimus, do they have the same platform inside? Because you've said that Fortimus does have timing options, it has a display, and Minimus does not.
Correct. So the Minimus is a Guralp platform. We designed it ourselves, and the same platform, basically the same boards, are within the Fortimus. So it is near identical. The Fortimus just has a few additional features that we've developed in the last year, and that is power over Ethernet, the ability to have the LED, the display, but in general it is identical.
So the Minimus does have timing options, like
Correct. They both have the same
time protocol and the same.
Yeah,
Okay.
they both have the same timing options.
But it does not, it cannot power itself via the Ethernet.
The 3-channel Minimus at the moment cannot. The 8-channel can. So what we're looking at in the future is allowing both models to power
And
over Ethernet.
what you call power over Ethernet, is it 802 international standard, or do you have implemented self-powering protocol? Like, is it compatible with what the telecoms call power over Ethernet, or is something that special?
I believe it's the general standard. However, let me confirm with our technical team.
Thank you very much.
No worries, thank you.
Тут я вкратце от себя добавлю, переведу немножко. Вот. Первая часть вопроса была про протокол GDI и про его совместимость. То есть Ханна сказала, что данный протокол через специальные плагины может передавать данные в программы как сейсcomp и Earthworm. Вторая часть вопроса была про начинку цифрового акселерометра Fortimus и регистратора Minimus. То есть они имеют, можно так сказать, одинаковые мозги. И так же как Minimus и Fortimus имеют все те же опции по синхронизации и опцию питания подачи напряжения через Ethernet-кабель.
Two questions. Moscow State University, Physics Department. Я по-русски можно? Да. Значит, первый вопрос. У вас на слайде были уровни шумов оборудования. И каким образом эти уровни шумов получены, особенно в той области, где они ниже, чем low noise model? Это первый вопрос. А второй вопрос. Partly digital feedback. Yeah? What part of feedback is digital? What socket is digital? What socket analog? So, thank you.
Okay, the first part of the question. You can switch to the slide where you show the noise model. Yeah, the second or third.
Sorry, we're getting there.
Further.
This one. Yep,
В начале, которая была. In the beginning.
we're going there. This one? Yeah.
How did you get such measurements? Так, еще раз. Как они получили? Did you measure these graphs or you calculated them?
So for the 60 and the ESPC, they're theoretical. For the 3T, so the lowest one, that's measured, and I can show you the measured graph if you would like. Yeah, so they've been done by third parties as well.
Самый нижний график 3T, он был реально померен при участии университета. Which university?
Liverpool and Southampton.
В Ливерпуле и Саутгемптоне. А остальные теоретические расчеты.
If you're interested, I can show you the true graph. Yeah, it's the Sleesman's. So they use the Sleesman's method, where you have the 3 sensors and you cancel out the external noise.
Используют специальный метод с использованием небольшого количества датчиков аналогичных и путем каких-то вычислений убирают собственный шум.
Yeah, if you're interested, I can show you some of the data and some of the true graphs.
Цепи цифровые и аналоговые для обратной связи.
Digital and analog.
What is the border between digital and analog part in radian?
We have mechanical components like a standard. So the actual mechanics is, as you would imagine, a standard seismometer with the analog system. But inside the radian, we also have an ADC converter. So the final bit of the feedback system will allow you to output in digital, and that's because one, we wanted to be able to have this instrument to be installed in a chain, like the one in Bishkek, which is so much easier if you have digital running through the chain. But also it reduces cable noise for boreholes and post holes.
Механическая часть полностью аналоговая. Дальше вот это вот снаряд, да, будем называть его так, он имеет встроенное ЦП, и дальше уже в цифровом виде передает данные либо на поверхность, либо если они выстроены в цепь, подвешены, то это намного проще передать данные в цифровом виде, чем гнать аналоговый сигнал снизу наверх.
There's no memory inside here, so once you stream the data in digital, the memory and the data is stored in this at the top, so this sort of acts as a surface interface where you can access the data and input the power.
Радиан как таковой не имеет собственной памяти и передает данные на минимус, который находится уже непосредственно на поверхности.
Okay.
Еще вопросы? Кто-нибудь желает? Any questions? Тогда я предлагаю, можем продемонстрировать работу программного обеспечения. Можно подойти, потрогать все это, повертеть. Вот. Так что давайте еще раз поблагодарим наших гостей.
Thank you. That is what I'm doing right now. Sorry, I was trying to get it on like whilst we were talking about the... So, what would you like to see? Nice. Do you want to just say that if anybody wants to come and see the software, then we can talk to them about it? Perfect. There's a guy from the left. Talking about the